Hello, and welcome to this session on Game of Streams, or how to tame and get the most from your messaging platforms. My name is Mark Heckler. I'm a Spring developer and advocate with VMware. If you think of something you want to reach out to me about after the fact, by all means, please do email me, or better yet, hit me up on Twitter. If you're following me on Twitter, that's great. If you're not, why? It's simple, MK Heck on Twitter. And that's where I kind of live on Twitter. So I do check email from time to time, but if you really want a faster response, Twitter is the way to go. If you want to send me something publicly, that's fine. Just tweet it out there and tag me. If you want to send something you don't want to share it with the world, a question, comment, or feedback, my DMs are open. So just send me a direct message and happily respond to you as soon as possible. Much faster probably than email. So, a bit about me. I have co-authored a couple of books, contributed content, and goes to several other books. I actually have another book in the pipeline I'll mention briefly momentarily. I am an architect and developer, and as you might surmise from the next point where most of my expertise has been won, it's been in the JVM ecosystem. I am a Java champion, a Java 1 rockstar, Groundbreaker ambassador, now a Google developer expert in Kotlin, because I love Java and Kotlin. I think that's possible. I don't think you have to choose your favorite child, so to speak, but yeah, I love them both. They both bring a lot to the table. I am a Spring developer and advocate with VMware. I do love to write Spring code. I do love to commit to Spring projects, and I do love to talk about writing code and committing and just writing better software, which is why I'm here. So thanks for having me. I am also the sole creator and curator of Spring Noticias en Español. Si eres hispanohablante, por favor, déjame extender tu voz. Okay? If you're not a Spanish speaker, that's fine. By all means, we all want to share resources better, and that's just my area that I feel like I could contribute to. So it's kind of a personal and professional passion of mine. I'm also a licensed pilot. Crazy, right? The amount of trust that government organizations will extend to you when you go through training and try to do all the right stuff, sort of. But yeah, I do enjoy flying, not for a living, but just as a nice avocation, if you will. So yeah, hit me up if you're ever in the area. I do have a new book coming out, as I mentioned, Spring Boot Up and Running, that I'm writing for O'Reilly. Just wrapping that up here over the next few weeks, so it should be out here soon. If you want to know more about it, if you want to even take a peek at some introductory, the first few chapters, right? They're not really introductory. I mean, they're not really proofs. They're actually in there, right? That's the actual chapters. So the first few chapters are available. If you follow the shortened link down below, bit.ly Spring Boot book, that will take you to the O'Reilly site, and you can check it out. And yeah, so that's it. Let's do a quick time check. We're doing well, under 3 minutes so far, so we still have most of our time to go. That's awesome. So how many of you at the end of the year, last year, your boss came to you and said, hey, you did a great job, but you're doing a little too much. Can you slow it down and let me double your budget? Yeah, that never happens, right? If it does happen, by all means, please let me know. I'd like to, request funding for a government study. That's probably really unusual, and we should probably write that up. But let's face it, most of us are asked at the end of each year, hey, great job. Please do more with what you have. Or, maybe even, worst case, do more with less. But whatever the case may be, we certainly almost always have tools at our disposal that we're not fully utilizing, that we're not fully leveraging. And that's kind of what this talk is about today. How to really use things you have and to get more out of them and to actually be able to do more cool stuff with them. So some of the takeaways. Well, we're going to start with why use messaging platforms in the first place and where do they fit into a distributed architecture. And then we'll go into some of these other topics, of course. I'm going to try to keep this section short so we can launch into the code, but I do feel it's important to understand why we're even talking about this, right? For starters, most of us have worked or are working on a monolithic type of a system, right? A monolithic architecture. And monoliths, like any other architectural choice, have pros and they have cons. They're very neat and tidy in terms of everything is in there, right? It's an all-in-one, sort of like going to a buffet. You're going to find something you need in there, and it'll probably cover everybody's particular needs, desires, whatever. The problem, I guess, well, as with any architectural choice, there are numerous problems, but probably the leading problem with monoliths is their scalability. Because what happens with a monolith, by definition, is you have a lot of different capabilities lumped into one thing, one deployable, testable, developed unit. And of course, the problem with that, especially when it comes to scaling, is that all parts aren't used equally. So I like to use the example of an online retailing platform if we were to develop that as a monolith. Now, I don't want to get into any kind of trouble in terms of like copyrights or naming and stuff. So we'll call it something entirely different it doesn't even resemble anything that anybody's doing. We'll call it Amazon. Because we're in the zone with this, right? This is going to be something new and big and completely different. So we're developing Amazon, and Amazon has this catalog. It has user accounts and logins. It has a catalog they can sort through and find things and search, and then when they pull something up, they say, yes, I really like that, and here's the size and the color I need of that shirt, or the configuration I need for that device, the amount of memory, storage, what have you. And then they choose that and they add that to the cart. Of course, that thing that they're choosing may or may not be in stock. It may or may not be available from the nearest distribution center. And of course, when they say, yes, I have that in my cart, I'd like to place that order, we need their information, their payment information, and their address and things like that. So all of that needs to be cross-checked with valid mailing addresses, their credit to make sure that we can legitimately charge them what they're wanting to charge for a purchase. And then we need to deal with logistics and how we're going to get that to them. And then, of course, if inventory levels are being depleted or fall below a certain level, we need to reorder from various different suppliers. So we need to manage suppliers. We also need to take into account that if they get something and they say, ooh, that's not the right size, that's not the right color, that's not the right memory configuration, you ship me a whatever, and it should have been whatever else. We need to be able to accommodate those returns. So all of these modules are lumped in a monolithic architecture into one thing. Now, I like to point to Black Friday sales in the US, which are kind of where all retailers go into the black. They get out of the red for the year, so they're not losing money anymore. They're suddenly in the black. They're suddenly profitable. And from that day forward to the end of the year, obviously you still have costs that are incurred, but that's where they say that they're in the black. That's where they make their money for the year, really. They've covered their costs for the year. They're just making money. They're printing money at that point. So at that point, Black Friday sales are huge. There's a lot of volume when it comes to in-person, some years, and online purchasing. So how many, just for a thought of experiment, how many returns do you think they get on Black Friday? Well, almost none, right? I mean, sales is hammered. The cataloging, the ordering, the shipping, that's heavily utilized. But that day, there aren't very many, if any, returns processed. Now, those may come later, and they almost certainly do, but they're not processed that day. However, if we need to scale that day and handle 2 times or 5 times or 10 times the load, and we have a monolith, what do? We pick up and duplicate that monolith. Now, setting aside the issues of contention, where you have 2 or 5 or 10 things that are trying to fight for the same resources and that kind of thing, we'll kind of sidestep that for the time being because that gets into a whole different conversation. But you're also, when you pick that up and you double or treble or whatever, you scale those numbers of monoliths up, you're also bringing along a lot of unused capabilities just by default. They come along for the ride, that kind of dead weight. So your returns module comes along and it's scaled to 2 or 5 or 10 times the number of returns modules, even though you don't even need one on that particular day. So scaling becomes a bit of an issue. What do most of us do when we see those issues? We start looking at things like a microservices architecture, teasing out functionality that's heavily used, that needs to scale, that's widely divergent in its demands, right? So some days you need a lot. Some days you don't need as much in terms of, let's say, the ordering module or maybe the returns module on a different day. So when we start teasing those out, we look at how do we make these various different services communicate? And that's most of the time where we start off with an HTTP-based architecture. So we have REST APIs, for instance, and our services communicate via those. What we realize, though, is that there are limitations even when we start doing that, because we don't typically tease out a microservice, we tease out small clusters of microservices. So if we tease out that order module, we also kind of typically will bring with it maybe a catalog module and a shipping module and a credit check module, because we need those capabilities to operate kind of as a cluster of capabilities, because they work together to fulfill a particular objective. And that's fine, but it certainly isn't quite as granular as maybe we would have liked or would have hoped. We also realize that when we do that, we start seeing some similarities, some ties, some coupling in terms of the scaling of those various different associated microservices. So if a catalog module needs to scale to 2 or 5 or 10 times the number of catalog instances, and it needs to, each time you add something from the catalog or to the shopping cart, you need to, well, in most cases, you'll have kind of a linear scaling there. So if your shopping cart needs to scale, you typically scale up roughly the same number of catalog instances, or vice versa. Same thing with credit checks and shipping and things like that. So you find this maybe a lack of decoupling that you might have expected, or at least a lesser amount of decoupling than you might have expected. So you start looking at that and saying, well, I'm seeing some limitations here. How do we take that one step further? And what I like to call next level scaling. Because you want to be able to separate in various different ways your producer of requests or messages, when we start thinking in terms of messaging platforms, and the consumers of those messages or requests, right? So with a messaging platform, that allows you to decouple in many ways your producers and consumers of requests, of messages, because you don't have to necessarily have them temporally coupled. You don't have to have them locationally coupled. You don't have to have them numerically coupled. And what I mean by that is, if a particular producer of messages is able to produce a certain number, but a consumer has to do quite a bit of intensive processing on each of those messages coming in, each of those requests coming in, you may need to scale that consumer at a much higher level than the producer of those same messages. And you can do that in terms of messaging platforms via various established patterns, and vice versa, right? They also don't have to be temporally coupled, because the producer of those messages can send off those messages, and even if no consumers of said messages are online at that point in time, depending on how you've set up your messaging platform, those messages can be sitting there waiting for a consumer to come online, which gives you a lot of flexibility in that regard, right? Locationally, of course, a consumer of the message doesn't need to know where a message came from. It just needs to know, hey, I have a message. I need to consume that. I need to do something with that. So it gives you a lot of flexibility that you wouldn't have if you had two services that have to be online and communicating together at the same time in order to complete a transaction, an interaction, right? So some examples of leading messaging platforms, and there are numerous options. I like to kind of bubble it up to the what I consider to be the top few, and I think are some of these are debatable, but I think they're all very good contenders, the ones that I typically point to. Your mileage may vary, but by all means, please do check them out. I like to start with RabbitMQ and Apache Kafka, because they are the big ones, right? They're the ones who have kind of been around a long time, who have established the performance patterns, have been used to leverage numerous and define numerous different patterns that are used for routing, for message handling, for scaling, for resiliency. And so you've got a lot of things that have been baked in and formed around these two leading messaging platforms. They also have a lot of flexibility, which I'll circle back on here in a moment. You also, from all of the various different cloud providers, have various different entries, whether those are RabbitMQ and Kafka hosted by them. In most cases, you also have different options that are provided by each of these. So Microsoft will have certain various different options that they offer you to consume on their platform. Same thing with Amazon, same thing with Google, same thing with Alibaba, and any even the second tier, what I call the second tier cloud providers, have options as well. I like to kind of bubble it up to the top ones. So even on each platform, so things like Amazon Kinesis or Microsoft's Event Hubs or Google Cloud's PubSub, Cloud PubSub, and then like Solace PubSub Plus, you have a lot of different options. But I still come back to, I guess, first among peers of RabbitMQ and Kafka, because they're well established, well proven. They're also 100% open source, which the other options that I mentioned and many other options are not. Maybe that's not an issue. Maybe that's a huge issue for you, but those are things to take into account when you make your decisions. Again, I like to start with RabbitMQ and Kafka because they're pervasive. They're everywhere. You can run them on everything from a container to a VM to a bare metal to a hosted platform to a major cloud provider. So, you have options. But we'll start there and we'll talk about some of the other things as well. Now, why bring Spring Cloud Stream into the mix here? Let's say you're using Kafka and you're happy with it. Well, we don't always get to choose and stay on a single entry within any particular domain. In fact, we rarely do. So even if your company has standardized on Kafka, if your company acquires or is acquired by another company that is, for instance, standardized on RabbitMQ, now what? You're back in the integration game. You're back in the realm of dealing with multiple different platform options. If you work with a partner or a customer who uses, let's say, Kinesis or Event Hubs, you're once again in the area of, even though we may have been able to, with great pain and effort, standardize on one particular messaging platform, now we're dealing with multiples. How do you deal with that? Well, as developers, of course, we want the full power of a particular platform we're using. But once we have things tweaked, we typically like to think of things at the highest level possible that makes sense so we can get more done, deliver more value to our customers and to our business, our organizations. And how do we do that? By not getting bogged down into the weeds any more than necessary. Make it as complex as necessary, but no more complex. Spring Cloud Stream raises the level of abstraction and allows you to deal with the things you need to deal with without always having to get down underneath the surface and deal with the plumbing underneath. Now you can, all of the configuration settings and whatnot are exposed, obviously, to you. You can get to them. But in most cases, as developers, we care about routing messages. We care about getting a message from point A to point B, or point A to point B, C, D, and E, or what have you. We need to make sure that things are delivered where and when they're supposed to be. And Spring Cloud Stream does that by focusing on the higher level of abstraction and working with binders for whatever platform you choose underneath the surface. Now, why use it? I think I've already covered that to some degree, so I'll make this brief. It gives you the flexibility to think at that higher level, to get more done, as well as to work with the platform that may make sense or that you've standardized at the time, while not closing out your options and giving you a lot of flexibility and what I like to call developer superpowers. Now, if your CTO reads a magazine article, reads an article online and says, hey, look, I know we've standardized on Kafka. I hear that this is the next big thing. Maybe we'll replatform everything to Kinesis. How long would that take? Well, you have flexibility. If you've built on something with something like Spring Cloud Stream, you've got the ability to, even though you've built on top of one thing, you can replace that entire underlying architecture very easily, that underlying platform. So maybe not tell your boss that. You don't want to encourage that kind of crazy, 180-degree turns, very frequently. But certainly it gives you a lot of capabilities and peace of mind that you can just charge forward and get the job done and satisfy and serve your business customers. So that's helpful, right? Now, a bit of what we're going to be covering today. I'm going to use Spring Cloud Stream to connect with an underlying messaging platform. I'm going to use Rabbit to start off with because I love Rabbit. Rabbit is crazy scalable. It also gives you routing flexibility like nothing else. Now, I say that, typically people think of Rabbit in terms of the routing flexibility and then Kafka in terms of scalability. There's a lot of overlap there, right? Because Kafka gives you good routing flexibility and RabbitMQ gives you good scalability as well. We've proven that out at the time. Pivotal and Google worked together to see just how far they could scale Rabbit, and they found that they could process almost 3 times the number of messages per second as were being created in the US in WhatsApp, iMessage, and text messages combined. So it's no slouch. Same thing with Kafka. It's no slouch in terms of routing. But I'll start off with Rabbit. I really like Rabbit. I really like Kafka too, but we'll start with Rabbit and we'll go from there. So these are the 3 predefined interfaces built into Spring Cloud Stream. And it makes sense, right? You have a source, which is the creator of values. You have at the other end of the pipeline a sink, which is the consumer of values. That's kind of the end of the line. That's where all processing stops, is completed. The life cycle of that particular message is done, right? In between, you may have one or more processors that will transform that message, act on it in some way, and then pass it on through a pipeline. And I do try to stay at that terminology level of pipeline, right? Because whether you're dealing with RabbitMQ's exchanges and queues or Kafka's topics, you're really talking about a pipeline to connect multiple things, right? To pass messages between things. So source, processor, and a sink, if you keep that in mind. Also, should time permit, and I'm not sure it will because we are a little tight on time today, but we'll see we're going to get through as much as we can, and whatever we don't cover, it's in the repo, which I'll share as well. But you can scale your sources, your processors in sync. I have it shown this way just because I think it looks nice, but certainly everything can scale out, scale in, to accommodate the various changes in workload that you experience with your applications, your distributed application. You have flexibility should you need to change the underlying architecture, the underlying messaging platform. You have the capability to do that with minimal disruption. If you've planned ahead, it can be zero disruption, zero downtime. It's just crazy the options that are at your disposal via Spring Cloud Stream, and I'll show you that as well. We'll run into that. We'll see that. You also have a lot of versatility because, as I mentioned, even in the best of scenarios, you can't always standardize on one underlying platform of any kind, messaging or otherwise, and stay on that because situations, circumstances sometimes dictate changes, right? I mean, life is full of changes. We need to anticipate those and be ready. And this gives you the versatility to do that. Now, just like a minute ago, I mentioned source, processor, and sync, and that makes a lot of sense. This is how Spring Cloud Stream was developed. And it was developed on Spring integration, using Spring Boot and Spring integration kind of to come together and make the magic happen, so to speak. But over time, of course, we realized that this is a bit of a leaky abstraction. If you're familiar with Spring integration, which brings together a lot of different options, which is great. Spring Cloud Stream focuses that solely on messaging platforms. But what we realize is if you're familiar with Spring integration, this makes a lot of sense, but we're kind of leaking details of Spring integration into that a bit. And with a kind of a step back and look, we realize that, our source, a processor, and a sync have parallels even at the language level in Java. So you have a source which produces values, a processor which transforms those values, and a sync which consumes them. These parallel nearly 100%, if not 100%, with a supplier, a function, and a consumer. And at the functional level, you have a supplier which creates values, a function which transforms values, and a consumer which consumes those values. It's perfect, right? So this allows us to actually get to eliminate some of that leaky abstraction, to take things down to the level, a very basic and fundamental level, and to compose these pipelines in a way that makes really a lot of sense, even at the language level. So this is kind of the evolved API. This is where we're headed with Spring Cloud Stream. I don't do a lot of talking about the legacy API, even though it will still be out there and supported for a long time to come. But this is the future, right? This is where we're going. It's much more modular, composable, more functional, and it does allow you to work with Spring Cloud Function as well, should you desire to get more into a function and serverless type of environment over time. So we'll also cover a few other useful bits and bobs if time permits. If not, again, those are in the repo and I'll happily come back to those. So let's code. Yeah, this is the fun and productive part, right? Time check. We're doing well. We've still got quite a bit of time. Good. So, all right, let's switch to our Spring Initializer. Now this is where we start when it comes to creating Spring Boot-based microservices. You don't have to start here. You can create your own bespoke, custom, artisanal Spring Boot-based microservices, but that's writing a lot of code that you wouldn't have to, right? It's doing a lot of stuff you don't need to do. This will do it for you. It's not a code generator, although it does create your main application class, main method. What it does do is allow you to select the capabilities you want, and it will set up your project with your build file, and boom, you're off and running. So you can go here to the Initializer site. You can curl it. You can HTTP it. You can access this from your IDE, and it's all the same artifact that's downloaded, and you just unzip it, and off you go in your IDE. So that's nice, right? It's consistent. I like to go here because it gives you a couple other capabilities, light mode and dark mode for one, which I know seems like a very minor point, but if you're used to dealing with dark mode every day and you go to some other tool that does this to you, that's a little jarring. We also have the ability to explore our project and our build file before we even download it and get started running. So that's nice. That's a nice little extra touch. The oft imitated start.spring.io Spring Initializer. So you have options here. I'm going to launch right in pretty quickly. If you want to use Maven for your build system, you can choose to create a Maven project. If you're a hipster, you can create a Gradle project. I'm not feeling the hipster today, but yeah, do what makes you happy. So we're going to choose Java, but you have options of Java, Kotlin, and Groovy. I'm going to stay with the production version of Spring Boot 2.3.3. You have options for upcoming snapshots and milestones, as well as the previous versions, a few previous versions. But again, production version is good. That's what's production, right? I'm going to change a little of the metadata to the hecklers.com. We're going to today create a source, a processor, and a sink, and we're going to tie those three different microservices together with our messaging platforms. I'm going to create a jar because it is, after all, the 21st century, so I'm going to use a jar packaging. I'm going to choose Java 14, current version of Java, and bring in a few dependencies. So I'm going to make a web, So I want to bring in reactive web dependency instead of this, because that way we can do some reactive stuff. Now, I'm going to be showing you the reactive, a little bit of reactive programming, but it's very minimal, right? I'm going to keep this fairly elementary because it's not the particular focus of today's talk, but it works. In the things that we're going to see, we're going to be dealing with reactive streams publishers, but they're very similar to like a reactive list of things. And that's a gross oversimplification. But again, for today, that's not what I'm focusing on. So we'll go with that. So I'm going to bring that in, and I want to show you some things with Actuator because that gives us our production ready capabilities in Spring Boot applications. I'm going to include Lombok because I'm a lazy developer, lazy good, not lazy bad. This allows me to reduce the boilerplate code, and I have strong feelings both ways using it in production. I know a lot of people love it, a lot of people hate it, but I find it's very useful for reducing boilerplate, especially in demos. It makes it really nice so I can, again, focus on the things that I want to show most. I'm going to bring in the dependency for Spring Cloud Stream. And as you can see, it even tells you, look, hey, if you're going to use Spring Cloud Stream, you're going to need a binder to bind to an underlying messaging platform. So such as Kafka, RabbitMQ, Solus, PubSub Plus. And as a hint, I'm going to take that hint. I'm going to bring in RabbitMQ and Kafka, and we'll just start there. And that should be good for now. Oh, to show you where you can explore the project before you even download it. It shows you your version of boot, your version of Java that you've chosen. It shows you your dependencies that you've chosen, and it lets you kind of sanity check that before you even pull down your project. So that's nice. And I'm going to save this to my desktop, and just in the interest of time, I'm going to also I'm going to just create all three of these projects, generate, there we go, and sync. Time is of the essence, and we want to waste none of it. So we're going to open that, and I'm just going to delete this. Oh, much happier. Okay. And let's open our source project. Now, I did have another project in the background, and this is what's going to be the feeder project, because as the domain, the topic, the subject area for today's demo, what I want to do is pull data from a device that I have here in the house, which is running and pulling down all flights in the area. So any aircraft that are within range of this device and antenna, it will pull in and it will report the current position of that particular aircraft. As I mentioned, I'm a pilot, but I also just an enthusiast, so I like to see kind of what flights are going on in the area. And even though there may not be necessarily that many flights at this point in time that are within range of my tiny little device with its tiny little antenna, I do like to kind of see what's happening. And just in case there aren't, I have something that'll feed just a Spring Airlines flight for some data to go on. So we have a lot of data that can be fed in. I'm going to actually take a small subset of that data for our demo purposes today. So I'm going to pull that every so often, and we're going to see what we get. So to start, we have our source, and I'm going to go to my POM because I want to show you. Part of Spring Boot's auto configuration, how it does its quote magic, is it will use your class path, your dependencies. It will check your code, your annotations, and it will say, look, I know what you're wanting to accomplish here. So let me help you. Let me create the beans that you need to make that happen. And of course, it relies on a certain set of logical rules to make that happen. So when you have Spring Cloud Stream, it expects a binder. When it finds a binder, it makes that connection for you. What happens if it finds two? Like we have RabbitMQ and Kafka here. Well, it needs a bit of direction. It doesn't know which you want to connect to. Maybe you want to connect to both, but you need to specify, because in most cases, you're going to connect to one or the other, right? Or a different option that you may include. So we need to provide a bit more information to disambiguate, if you will, what you want it to do, which we'll do in our application properties file momentarily. So let's go to our code. We're going to create a little bit of code. I start with my domain class. Boy, IntelliJ is having a little trouble keeping up right now. So that's a little sad, but I think we can still make this happen. So I'm going to create an aircraft class, and it's actually an aircraft position, but it's aircraft at a position, right? And I'm going to just define a few member variables here, like call sign and registration number and flight number and type of aircraft and come on, IntelliJ, keep up. And I want to be able to capture the altitude. Spelling is important, right? Heading and speed of that particular aircraft at that particular moment, talking is hard too, and the latitude and longitude of that aircraft. Now, I'm going to make this a data class. Lombok will create my getters, setters, equals, hashcode, and toString methods if I just annotate this as a data class. And I'm going to ignore any properties that are unknown that may be fed in. As we saw, it will probably feed in a lot of properties here that we don't necessarily care about. So I'm just going to ignore those at this point in time. So what I like to do is to create a configuration class in which to define my beans. Now you can define your beans up here in the Spring Boot application class. It's also a configuration class, but I like to keep things a bit more separate than that. It's, again, entirely up to you. So this will be our position feeder class, and I'm going to define a bean. And actually, what I would normally do is define a bean. But what I'm getting from our feeder, our position feeder, our plane finder, if you will, is a grouping. So I'm getting a list of current aircraft positions. But what I want to do is reactively keep a publisher open. So I want to poll for these groupings every so often. So I make this a pollable bean. And again, happily discuss that further at length at another time, but we're going to keep rolling forward at this point. And I'm going to supply downstream a flux of aircraft. Import, there we go. And we'll call this send positions. And a supplier is a functional interface with a single abstract method. And since Java 8, what have we been able to do when we have a functional interface and a single abstract method? We supply a lambda, right? Exactly. Now, we need something in order to poll our device and get that information. So that's where we're going to create a web client, a reactive web client equals, we're going to do a web client.create, and I'm going to point to our localhost 7634/aircraft. And this will be where we poll for those aircraft positions. So I'm going to access my client. I'm going to do a get. I'm going to retrieve those values, convert the body to a flux. So this is the body, the response body, and this will be a flux of aircraft. I'm going to filter this. So some of the aircraft coming in, aircraft positions I've noticed, don't have a registration number, have a blank registration number. And we want to make sure that we don't bring those in. Doesn't hurt anything really. It just makes things a little cleaner, right? So I'm going to take this, and this is a pretty simple lambda, but this will supply a flux of aircraft, a reactive publisher of aircraft to whatever's downstream. So I'm going to start off and just set the server port equals 0 for Spring Boot applications. This means that it grabs any available port and uses that on startup, so we don't have to deconflict our ports and avoid port conflicts and things like that. So that's kind of useful. I'm also going to set my my Spring Cloud Stream default binder, and this is a way to kind of do a single binder for all uses within that application. So I will and won't use this depending on the time frame or the circumstances, but it's nice to use in circumstances like this because a source has no input channels. It has output channels only. It is the source of values when it comes to messaging pipelines. So I'm also going to set up my bindings, and you use the method name for your channel, right? So we have an output channel and 0. We only have 1, but we can have up to 8, 0 through 7. And I'm going to set the destination to a pipeline. We'll call it processor. Yeah, that looks good. And let's see, so what else do I want to do? Oh, I want to be able to use Kafka here in a bit. So I'm going to have Kafka, have our Spring Cloud Stream application add default or add partitions as needed. I'm going to start with 4. And then I want to define my management endpoints, what to include. This is for actuator. Now, I do want to say, let's see, I'm having to look around my, my microphone here. So there we go. Please do not do this in prod, right? And the reason being, with actuator, you can include endpoints to expose, or you can exclude certain endpoints. I'm with a wildcard here. I'm exposing everything to everyone, which means that you're going to potentially expose a lot of very useful information to outside potential attackers. You don't want to do this in a production environment. This is great for a demo, not in prod. So I'm going to expose everything with no security. Do not do this in prod, but it works for now. So this is our source. We have this up and running. Let's go ahead and create now our processor and our sync. We'll move along pretty quickly with this because some of the steps are much the same. Pardon me. Okay, so once again, we'll go to our application properties and our application code. Now, in the interest of time, what I'm going to do is just go back here, and I'm going to grab my domain class. Please don't tell anyone. Good thing this isn't being recorded, right? And I'll make this an ALEX constructor. And then, since this is our processor, this is our transformer. What we're going to want to do is transform aircraft into something else. I'm going to call this essential aircraft because this is the essential information we're wanting to pass on downstream. So private string, call sign, let's see, so reg, type, and manufacturer. Let's do the manufacturer, and then we'll set up our, let's see, essential aircraft, string call sign, string reg, string type. There we go. And let's see, this dot call sign equals call sign. This dot reg equals reg. This dot type equals type. And I'm going to set manufacturer. Boy, typing is hard all of a sudden. I'm going to use the type. Now, I'm going to create the method here. And again, sadly, in the interest of time, I'm going to have to copy this, and you'll see why momentarily, because what I'm going to do is bring over some types. Now, these are different aircraft types, and what this, let's see, there we go, that looks a little happier. Okay, so based on the type, we can determine what the manufacturer of that aircraft was. And of course, there are many, many more. These are just a small collection that I've assembled to kind of speed us along. And then again, we're going to create a configuration class, and this will be our aircraft transformer class. And this will be a bean. And here, for our processor, we have a function which takes a flux of aircraft coming in, right? This is what we're passing in. And we're going to then produce a flux of essential aircraft going out. And we'll, let's see, transform AC. There we go. Once again, a function is a functional interface with a single abstract method. So we're going to take our aircraft flux, and we're going to map each one of those values to a new essential aircraft. We're going to use our call sign. We're going to use the registration coming in, and we're going to use our type coming in. And then I'm just going to log that so we can see what's happening as it happens. So I'll go up and grab my function. And oh, so many things I want to show you, and we're just not probably going to have time. but that's fine. That leaves some good stuff for down the road, right? So we have an input channel. So this is our processor, our transformer. So we have input channel and output channel, or channels potentially. But we know we're going to be getting things via processor, our channel defined as processor. We also can set up a group, and this allows us to define a consumer group. This is how you would implement the competing consumer pattern, so you can scale out. If you don't do this and you have different consumers, different processors that are connecting and pulling off these messages, and they're not in the same group, they're all getting the same copies of the same messages. So you're doing a fan out pattern, and that's a legitimate pattern, right? But if you want to scale, you need to have them take turns and process many more messages just by scaling out. And that's how you implement the competing consumer pattern with a consumer group. So I'm going to, and also I should say here, my bindings transform AC in 0 dot binder, and I can define here a binder. We'll say it's Rabbit as well. So Spring Cloud Stream bindings transform AC. We now have an output channel we need to define because this is a function, right? So destination, we'll point this to sync. We don't need a consumer group, because on our output channel we're not consuming, we're producing, right? So Kafka auto add partitions true, and once again our minimum partition count 4. Our management endpoints include everything again, and once again, don't do this in prod. Okay, so our processor is ready to go. We only need to create our sync, and we have 4 whole minutes left. Yeah, no problem at all. So we open up our sync project, and we go to our application properties, and we go to our application class. And once again, just due to time, I'm going to grab here our essential aircraft, and we'll keep this pretty simple, right? And we'll make this at data at $constructor, and let's see here. So at configuration class, and this will be our aircraft consumer. Create a bean. This is a consumer, as you might imagine, of a flux of essential aircraft. You can do it, IntelliJ. There we go. Okay, so we'll just call this logit. Return, and this is our AC flux, and we will take our AC flux and we will subscribe to that, and we'll just print it off, right? Print line, that works. Okay, there we go. And we'll go back to our properties, server port 0, Spring Cloud Stream bindings, and we have an input channel, just an input channel in this case because it's a sync, and we'll point that to sync. Once again, we will define the group here, and oops, let's just duplicate. We'll do the Spring Cloud Stream default binder Rabbit, and then Kafka, and true, and minimum partition count 4, management endpoints, again, not in prod. Okay, so we're off to the races. Let's go ahead and start our sync. Things always work perfectly the first time in live demos. I'm sure this will be fine. We'll see. Yeah, so. Okay, we're up and running with our sync. Connected to Rabbit, that's great. I need to do one other thing here that I skipped over, and that is to just create, annotate our essential aircraft with @data. So let me go ahead and restart that, or start that, excuse me. Get that up and running, and then we will go to our source and start that. And we're feeding data. Wonderful. Okay, so we'll go to our sync. Everything is coming through just fine as we expected, because again, things always work perfectly in, in live demos. So would love to show you much more, but time simply will not permit it. So let's just go back to our slides, and we will wrap up from there. If you're interested in finding out more, please check out the repo at Game of Streams Aircraft Edition under my GitHub account, MKHeck. If you want to know more about Spring Cloud Stream, the Spring Cloud Stream project page is right there. Ping me at email, or better yet on Twitter if you have any questions, comments, or feedback later on. If you love Kotlin, check out the Kotlin edition of the repos at the link below. And again, there's so much more, so please check out the repos, start the repos, watch them, as I'll be adding to them over time. Thank you for coming. Have a great day.